Imagine for a second, you wake up tomorrow and the headlines aren't about politics or the stock market. They're about a discovery that changes, well, everything. In a quiet, remote desert, a craft of unknown origin has been found. It's sleek, seamless, and completely alien. We have it. The very technology that has haunted our dreams and our skies is finally sitting in a hangar. You'd think this would trigger the greatest technological leap in human history, a shortcut to the stars, but the truth is, we wouldn't even know where to start. And this isn't a story about secret government cover-ups or conspiracy theories. This is the story of the real science, of why alien technology is likely so far beyond our reach that even holding it in our hands would be like a caveman trying to understand a smartphone. It's a humbling, and maybe even a terrifying thought. Why would we be so lost? What's the massive gap that separates our best engineering from the physics of a truly advanced civilization? The answer isn't that we can't see it, but that we might not be able to comprehend it. This is a journey to the very edge of our understanding of matter, energy, and even reality itself. Let's really paint the picture. This object is resting in a climate-controlled hangar, the prize of a frantic, secret global effort. It's not some riveted metal saucer from an old movie. It's a smooth, dark, egg-like shape. Its surface seems to shimmer and shift in the light, almost like oil on water, but with a depth that makes no sense. There are no joints, no seams, no bolts. No exhaust ports, no intakes, no wings. It's a perfect, unbroken form. At first, the excitement is electric. The world's greatest minds are all there, Nobel laureates, leading materials scientists, the sharpest people in aeronautics and computer science. You can feel the promise hanging in the air. This thing could be the key to it all. Unlimited clean energy, faster than light travel, cures for every disease. It's the ultimate treasure chest, and we're standing right in front of it, ready to crack it open. But as days turn into weeks, a creeping dread starts to set in. The team can't open it. They can't even scratch it. Their most powerful industrial lasers, which can slice through feet of steel, just reflect off the surface without leaving a mark. Their diamond-tipped drills powder into dust. It's like they're trying to sculpt water with a hammer. This whole situation would make us a perfect modern-day example of what anthropologists call a cargo cult. The term came from watching isolated island communities after World War II, who saw military cargo planes land and dispense incredible goods: food, steel tools, medicine. After the planes left, the islanders tried to bring them back. They built life-sized replicas of the planes out of straw and wood. They carved headphones from coconuts and sat in makeshift control towers, perfectly mimicking the air traffic controllers they'd seen. They had the shape, but they had zero understanding of the principle. The effect cargo from the sky was clear, but the core's aerodynamics, internal combustion, global logistics was pure magic. We, with our alien artifact, are the new cargo cult. We can see the object. We might have even watched it perform impossible maneuvers before it came down. But we're just like the islanders, staring at a straw airplane and praying for it to bring us cargo. We have the answer in our hands, but we don't even understand the question. It's an answer too. This is the core paradox of trying to reverse engineer something truly advanced. It's not like a rival country building a new fighter jet. We can take that jet apart, piece by piece, analyze its alloys, and figure out its engine. It's tough, sure, but it operates on the same physics we already know. The alien craft, though, is a completely different beast. It might not be an evolution of our technology. It could be a manifestation of a completely different tech tree, grown from the soil of a physics we haven't even discovered yet. And to even begin, we have to confront the very stuff it's made of. The first wall we hit isn't engineering. It's matter itself. We've gotten really good at making things. We've gone from stone and bronze to crafting materials that would look like straight-up magic to our ancestors. We have superalloys for jet turbines that can operate at temperatures that would melt iron. We have carbon fiber composites, lighter and stronger than steel, that make up our race cars and airliners. We're even poking at the edges of things like graphene, a sheet of carbon just one atom thick, with properties so wild it's promised to revolutionize everything. We should be proud of our mastery over the material world, but faced with a piece of an alien craft, all that expertise might as well be child's play. The material of this hull isn't just stronger or lighter or more heat resistant. It could be something else entirely. It could be programmable. Today, our scientists are just starting to explore this idea with something called metamaterials. These are materials that get their properties not from their chemistry, but from their tiny microscopic structure. Think of a material made of microscopic, intricately designed blocks that can bend light in unnatural ways, making an object invisible at least to certain frequencies of light. Or a material that could change its stiffness on command, going from flexible as rubber to hard as steel. We're learning how to design these structures, but actually making them is another story. An alien hull could be a single, vast metamaterial, a substance where the atomic structure is precisely arranged to give it impossible strength, its lack of a heat signature, and maybe even its ability to interact with gravity. When our scientists put a sample under their most powerful microscopes, they might see a crystalline lattice so complex and perfect it couldn't possibly have formed naturally, and that brings us to the next impossible hurdle: manufacturing. Even if we could get a perfect, atomic-level blueprint of this material, how could we possibly build it? It might require assembling atoms one by one with perfect accuracy over an area of hundreds of square meters. Our current nanotechnology can spell out a company logo with a few dozen atoms in a lab. Using that tech to build a spaceship would be like trying to build the Great Wall of China with a pair of tweezers and a handful of sand. This creates a brutal, looping problem. To build the alien ship, you need the alien factory. And to build the factory, you probably need tools made from the alien material itself. You can't create the technology without already having the technology. It's a perfect circle with no way in. Think of it this way: give the blueprints for a modern microprocessor to the most brilliant engineer from the Victorian era. He understands electricity and logic, and he can read the diagrams, but he simply cannot build it. The blueprint calls for transistors, mere nanometers across, etched onto near-perfect silicon. His world is one of gears, steam, and vacuum tubes the size of light bulbs. The materials and techniques required aren't just advanced to him. They're conceptually non-existent. He can't make the stuff the blueprint is made of. The alien material could be even weirder. It might involve stable isotopes of elements we've only ever glimpsed for microseconds in a particle accelerator. It could be a material that forces us to rethink what solid even means. Faced with this, even if we had a piece of it, we'd be left holding a miracle we could neither copy nor comprehend. But the impossible hull is just the start. The truly mind-bending problem is what makes it go. So, how does it move? This is the question that would haunt the dreams of every physicist on the planet. The craft shows no signs of any propulsion we'd recognize, no scorch marks from rockets, no ionized air from advanced jets. Eyewitnesses or any data we could pull would describe silent, instant acceleration, jumps from a dead stop to hypersonic speeds in a blink, right angle turns that would liquefy a human pilot and shred any plane we've ever built. This isn't just a better engine. It's a new rulebook for physics. Our entire history of getting around is based on Newton's third law. For every action, there's an equal and opposite reaction. We throw hot gas out the back of a rocket to push it forward. We push air or water backward to move forward. We are masters of pushing stuff, but the alien craft doesn't seem to be pushing against anything at all. It seems to be telling space itself what to do. This points directly to manipulating the fundamental forces of nature. As we know them, there are four: the strong and weak nuclear forces, electromagnetism, and gravity. We have a pretty good handle on electromagnetism. It powers our entire civilization. But gravity? We're just passengers on the gravity ride. We can fight against it, but we have no control over it. We can't turn it on or off. We can't reverse it. An advanced civilization might see gravity as just another engineering tool. Anti-gravity is a Sci-Fi staple, but the physics is mind-bending. Many theories require something called negative mass or negative energy. Normal matter, the stuff we're made of, has positive gravity. It pulls things together. Negative mass would do the opposite. It would have anti-gravity. It would repel everything. Stranger still, if you pushed a ball of negative mass, it would accelerate towards you. It's a purely speculative idea that seems to break our most basic laws of energy. A more mainstream, but equally out there idea is the Alcubierre warp drive. Proposed by physicist Miguel Alcubierre in 1994, it's a clever way to travel faster than light without technically breaking Einstein's laws. The drive creates a warp bubble around the ship by contracting spacetime in front of it and expanding it behind. The ship itself stays still inside the bubble, while the bubble moves through spacetime at potentially enormous speeds. It's a brilliant mathematical solution, but there's a catch. To make it work, it requires a huge amount of that same hypothetical substance, negative energy. The original math called for an amount of negative energy equivalent to the mass of Jupiter. While newer theories have lowered that number, the need for this exotic, unproven stuff remains. It's like having a blueprint for a car that needs a gallon of unicorn tears to start, or maybe the propulsion system taps into something even more fundamental, the energy of empty space. Quantum field theory tells us that a vacuum isn't really empty. It's a fizzing sea of virtual particles popping in and out of existence. This is called zero-point energy. We know this energy is real. A phenomenon called the Casimir effect proves it exists, but the amount of energy we can actually observe from it is minuscule. For us, trying to harness this energy to power a starship would be like trying to power a city by capturing the energy of a single falling raindrop. So, the problem isn't that we need a better rocket. The problem is the engine might run on a fuel we don't know exists, using physics we haven't discovered to manipulate reality in a way we thought was impossible. We wouldn't just be trying to reverse engineer a machine. We'd be trying to reverse engineer an entire chapter of physics from a single, silent, and uncooperative example. Thinking about this stuff can feel like trying to bend space-time with your own brain. It's overwhelming, humbling, and incredibly fascinating. And while we can't offer you a personal warp drive just yet, we can offer you more food for thought. We're a small team dedicated to deep dives into science and the universe. We spend hundreds of hours on these videos because we think these big questions matter. If you enjoy exploring them with us, please consider subscribing or supporting us directly on Patreon. Your support is what lets us tackle these huge topics and get the science right, all while keeping our videos free for everyone. Okay, back to the impossible. Let's pretend for a minute we overcome those first two impossible hurdles. By some miracle, we figure out the material and the new physics. Now, an even stranger problem appears. How is this thing controlled? What is its brain? Inside the craft, we might find something that looks like a cockpit, but it would have nothing we'd recognize as a control panel. No buttons, no switches, no keyboards, no screens. Maybe just a single, strangely shaped chair. There would be no visible computers, no server racks, no wires. The seamless design from the outside continues within. The entire ship feels like one single integrated object. Our technology, from a pocket calculator to a supercomputer, is all built on one thing: binary logic on silicon chips. A world of ones and zeros. Even our most experimental brain-computer interfaces are still just translating the analog electrical signals of the brain into the digital language a computer understands. We're great at it, but it's the only technological language we know. An alien intelligence might not use that system at all. Their computation could be woven right into the fabric of the ship. What if the control system is biological? What if the ship is a living organism or a biomechanical hybrid that was grown instead of built? Is the pilot not a separate person, but something that physically and mentally merges with the craft, their thoughts becoming the ship's commands? Or maybe the ship's mind is a quantum computer of staggering power. While we struggle to keep even a few hundred quantum bits, or qubits, stable for fractions of a second in supercooled labs, the alien craft might operate a room temperature, perfectly stable quantum computer with billions of qubits integrated into its molecular structure. A computer like that could perform calculations that would take our best supercomputers longer than the age of the universe. Its software would be written in the language of probability and superpositional language, where we're just learning the alphabet. Going even further, you can look at the work of physicist Stephen Wolfram and his concept of the ruliad, the entangled universe of all possible computational rules. Think of it this way: our entire system of math and physics is based on one set of rules. But what if there are other, equally valid sets of rules out there? An alien intelligence might have discovered and built its entire science on a completely different part of the ruliad. Their technology, then, wouldn't just be an advancement of ours. It would be logically alien. Its operating principles might be incompatible with our way of thinking. Trying to decipher their computational system would be like trying to run a modern VR game on a mechanical abacus. The very logic is from another universe. We might capture the ship's data streams, but to our computers, it would just look like random noise. We wouldn't even recognize it as information because our definition of information is tied to the computational rules we know. We'd be deaf to the ghost in the machine. So far, we've been running with a huge assumption that we actually have a crashed alien ship in a hangar somewhere. We've explored the massive scientific gaps that would stop us from understanding it. But now we have to turn from theoretical physics to the much murkier world of human testimony. What if the biggest reason we can't reverse engineer alien tech is the simplest one of all? What if we've never found any? The myth of the crashed UFO is burned deep into our culture. And the story usually starts in Roswell, New Mexico. In 1947, it's the foundational legend, a flying saucer crashes. The military recovers the wreckage and alien bodies, and a massive cover-up begins. This story, and others like it, have been fueled for decades by whistleblowers, secret documents, and grainy photos, creating this powerful narrative of a government hiding world-changing secrets. But when you look at the official record, a very different story emerges. In recent years, the US government has actually become more transparent about this. The Pentagon created the All-Domain Anomaly Resolution Office, or AARO, to investigate these very claims. After reviewing decades of classified data and conducting numerous interviews, their public reports have been clear and consistent. They have found no credible, verifiable evidence that any object of extraterrestrial origin has ever been recovered. The AARO reports systematically debunk the big claims. They found no evidence of secret reverse engineering programs. They investigated specific allegations like a proposed effort called Kona Blue and found it was just a concept that was never even approved, mostly because it was based on the hope of finding alien tech, not on any actual discovery. AARO concluded that most UAP sightings are just misidentifications of normal things, weather balloons, drones, new aircraft, or even airborne junk like plastic bags. The few remaining unresolved cases simply suffer from a lack of good data. So what about Roswell, the cornerstone of the whole mythology? Decades of US Air Force research have declassified the truth. The debris found on that ranch wasn't a flying saucer. It was from a top-secret, high-altitude balloon program called Project Mogul. This project used long trains of balloons with sensitive microphones to listen for the sound waves of Soviet atomic bomb tests from the upper atmosphere. The strange, foil-like material and wooden struts that witnesses described perfectly matched the materials used in those balloon arrays. The initial press release about a flying disc was a mistake by a local officer, which was quickly corrected with the weather balloon story to protect. The highly classified project, many of today's claims seem to be the result of what investigators call circular reporting. A small group of people tell stories they may genuinely believe. Those people repeat them, and soon a single second-hand story is reported by multiple sources, creating a powerful illusion that the story is confirmed when it's not. AARO found that many supposed whistleblowers were just repeating stories they'd heard from someone else, who heard it from someone else, with no one having any direct evidence. This doesn't mean people are lying. It just shows how easily stories can take on a life of their own, especially when they're stories we want to believe.